Okay, each of these four examples dealt with solving exponential equations, and in order to solve an exponential equation, you need to employ a logarithm, either by performing a logarithm on both sides of the equation or converting the statement eventually into a logarithmic one. So here you have 945 equals 210 times 1.03 to the t. You want to isolate this t. So first you would divide both sides by 210. I personally like having the variable on the left-hand side, so that would isolate the 1.03t on the right up here, but I moved it to the left. And 945 divided by 210 is 4.5. Now, you want to do a logarithm to both sides of this. It doesn't really matter which logarithm you do. The two main ones, and the two that are easiest for most people to access on their calculator, of course, is log base 10 and the natural log, log base e. So here, just going to use a common logarithm on both of these. Now, at this point, the log of 4.5 is just a number. It's going to be irrational, so for the time being, I'm just going to leave it as the log of 4.5. This here, I can move this t now in front and make it a multiplication. And likewise, this log of 1.03 is just a number. I have this number times t equaling this number. And so to isolate t, I'm going to divide both sides by the log of 1.03. And so t is going to equal the log of 4.5 divided by the log of 1.03. And if you carry this out, you get approximately 50.8842 when you round to 4 decimal places. Now you could always check these. I'm just going to show it for this one by always putting it back into the original problem. So does this 210 times 1.03 to this power give you the 945 that you want? How well it does this depends on how many decimal places you keep, but if you calculate this out, you do get about 945, which does verify that that is the answer. In this one here, you were asked to rewrite this 1,672 times 1.205x and write it as a power of e instead. So the constant being multiplied to this is still going to be the initial value of 1,672. That's not going to change. In order to figure out what's going to go here, and oftentimes this is called k, or the exponential growth rate, or the constant growth rate, that's going to be calculated by realizing that e to whatever this power is going to equal this 1.205 over here. So you want to solve the equation essentially of 1.205 equaling e to the k. Well, you could employ a natural log on both sides, or just rewrite this as a logarithmic statement, because the whole idea is that the natural log of e just becomes 1. It cancels. So k, whatever's going to be up here, is going to be the natural log of 1.205, which is approximately 0.186479, so forth and so on. So to 4 decimal places, you'd have 0.1865. For this one here, you want to solve this equation for x. So first, you need to get rid of everything attached to the exponential function. So this 15 that's being multiplied needs to be divided away. Now you employ a logarithm. You could either do a logarithm on both sides or just rewrite this as a logarithmic statement. I use the natural log because it just cancels with the e, because what happens is this x plus 4 gets moved in front. It becomes a multiplication with the logarithm, but the natural log of e is just 1 again. So you have x plus 4 equaling the natural log of 3.2. Again, notice that I'm not turning this into a decimal yet, because I want to keep this as exact as possible, and I only want to round in the final answer. This, however, is just a number. It's going to be a number. It's an irrational number, but it's still just going to be a number. So if I want to isolate this x here, I'm going to subtract 4 from both sides, and I'll get the natural log of 3.2 minus 4. So this would be an exact value. And when you take the final exam, this is the kind of value you're going to report for solutions, because you won't have your calculator to figure out what the natural log of 3.2 is. But because right now you do, you can now evaluate this on your calculator, and you would get approximately negative 2.8368. Another type of situation is having two different bases raised to two different powers of x, and you want to figure out what x is to make this equation true. So you want to solve this equation. Again, you would just use a logarithm on both sides. In this case, because it works well with the e, I'm going to use natural log, but you could use a log base 10 as well. You just have to keep the logarithms around more and things won't cancel as nicely, but you would still get the same answer. So the natural log of e to the x plus 1 is going to equal the natural log of 2.5 to the 3x. In each one of these cases, the exponent would get moved in front and made a multiplication. Here, though, when you do that, you would have x plus 1 times the natural log of e, and that natural log of e would just cancel, so you have the x plus 1. Here, you're going to have the 3x times the natural log of 2.5. Now, to solve this equation, you need to get your x terms all on one side. Here, I have 3 times x times the natural log of 2.5. The natural log of 2.5 and 3 are both just numbers. So I have the product of 3 and the natural log of 2.5 being multiplied to x here. So it'd be a good idea for me to move all x's on this side. I'm going to subtract x from both sides. Now, because I'm not evaluating what the natural log of 2.5 is yet, because again, that's going to be an irrational number, I would have to round it in order to report it. It'd be better just to keep it as it is, but that does prevent me from doing an easy combination of the two x terms. So the way I'm going to do it here and show it is to factor out the x that both of these terms have. When I factor it out of the first term, I'm left with 3 times the natural log of 2.5. When I factor it out of this term here, I'm going to be left with 1. So this is the same thing as having x times the quantity, 3 times the natural log of 2.5 minus 1. All of this expression is just a number. So I have some number times x equaling 1. To isolate x, I would divide both sides by this number. So I'm dividing both sides by 3 times the natural log of 2.5 minus 1. So x is going to be 1 over 3 times the natural log of 2.5 minus 1. Here is where I can now evaluate this. And when I do, to 4 decimal places, I get about 0.5718. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please make sure to bring them up during our class session.